Introduction standards. Human beings have always been innovative and have exploited the natural resources of the earth to manufacture products and devices that satisfy their basic needs and desires. They have always experimented with the form, size, and performance of the product they have invented. During the medieval period, the measurement process underwent an evolution and people accepted the process in specific trades, but no common standards were set. Generally, the measurement standards were region dependent, and as trade and commerce grew, the need for standardization was also realized. In fact, it would be impossible to imagine today's modern world without a good system of standards of measurement. Mass production, an idea generated during the last industrial revolution, has become very popular and synonymous with the present manufacturing industry and a necessity for manufacturing identical parts. Today, almost all manufacturing units practice the principle of interchangeability of manufacture. In order to accomplish complete interchangeability of manufacture in industries, it is essential to have a measurement system that can adequately define the features of the components, products, to the accuracy required. In order to make measurements a meaningful exercise, some sort of comparison with a known quantity is very essential. It is necessary to define a unit value of any physical quantity under consideration such that it will be accepted internationally. It is not sufficient to only define these unit values of physical quantities. These should be measurable. A standard is defined as the fundamental value of any known physical quantity as established by national and international organizations of authority, which can be reproduced. Fundamental units of physical quantities such as length, mass, time, and temperature form the basics for establishing a measurement system. In the present world of globalization, it is impossible to perform trade in national and international arenas without standards. In fact, a good system of standards is essential for fair international trade and commerce. It also helps accomplish complete interchangeability of manufacture. Adhering to globally accepted standards allows the manufacturer to convince the customers about the quality of the product. Standards play a vital role for manufacturers across the world in achieving consistency, accuracy, precision, and repeatability in measurements and in supporting the system that enables the manufacturers to make such measurements. Evolution of standards. The need for accurate measurements has been recognized by human beings since early times, which is evident from history of standards. Length standards were one of the earliest standards set by human beings. A brief look at history reveals the following interesting facts. The Egyptian cubit was the earliest recorded length standard, the length of the pharaoh's forearm plus the width of his palm. The royal cubit was the first master standard made out of black granite which was used in Egyptian pyramid construction. The actual foot length of the Greek monarch was defined as foot. King Henry I decreed the length from the tip of nose to the end of the middle finger when the arm is fully stretched as 1 yard. One of the important prerequisites from progress in science is to gain mastery over the science of measurement. Any progress made in manufacturing and other business sectors in the international arena necessitates that activities at high specific scientific and technical levels be accomplished by progress in metrology. Further, automation in manufacturing industries demands a very high level of accuracy, precision, and reliability. It is pertinent to mention here that human beings' knowledge of nature and the universe, their adaptability to the purpose, and their ability to measure precisely provides a basis for the science of metrology. Basic units of SI system. In October 1960, at the 11th General Conference on Weights and Measurements held in Paris, the original metric standards were redefined in accordance with the 20th century standards of measurement and a new revised and simplified international system of units, namely the SI unit, was declared. SI stands for System International Unities, International System of Units. The 7 basic units established under the SI unit system are given in the table. Working standards, these are used for more uh, frequently in workshops and laboratories. When compared to the other 3 standards, the materials used to make these standards are of low grade and cost. These are derived from fundamental standards and suffer from loss of instrumental accuracy due to a subsequent comparison at each level in the hierarchical chain. Working standards include both line and end standards. Classification of standard based on purpose table. Line and end measurements. We all know that sometimes distances have been measured between 2 lines or 2 surfaces, or between a line and a surface. When the distance between 2 engraved lines is used to measure the length, it is called line standard or line measurement. The most common examples are yard and meter. The rule with division marked with lines is widely used. When the distance between 2 flat parallel surfaces is considered a measure of length, it is known as end standard or end measurement. The end faces of the end standards are hardened to reduce wear and lapped flat and parallel to a very high degree of accuracy. The end standards are extensively used for precision measurement in workshops and laboratories. The most common examples are measurement using slip gauges, end bars, ends of micrometer anvils, vernier calipers, etc. For an accurate measurement, it is required to select a measuring device that suits a particular measuring situation. For example, a direct measurement of the distances between 2 edges. A rule is not suitable because it is a line measuring device. However, a comparison of characteristics of the line and end standards clearly shows that the end standards provide higher accuracy than line standards. Characteristics of line standards. The following are the characteristics of line standards. Measurements carried out using a scale are quick and easy and can be used over a wide range. Even though scales can be engraved accurately, it is not possible to take full advantage of the accuracy. The engraved lines themselves possess thickness, making it difficult to perform measurements with high accuracy. The markings on the scale are not subjected to wear. Undersizing occurs as the leading ends are subjected to wear. A scale does not have a built-in datum, which makes alignment of the scale with the axis of measurement difficult. This leads to undersizing. Scales are subjected to parallax effect, thereby contributing to both positive and negative reading errors. A magnifying lenses or microscope is required for close tolerance length measurement. Characteristics of end standards. End standards comprise a set of standard blocks or bars using which the required length is created. The characteristics of the following standards are as follows. These standards are highly accurate and ideal for making close tolerance measurement. They measure only one dimension at a time, thereby assuming more time. The measuring faces of end standards are subjected to wear. They possess a built-in datum because their measuring faces are flat and parallel and can be positively located on a datum surface. Groups of block or slip gauges are wrung together to create a required size. Faulty wringing leads to inaccurate results. End standards are not subjected to parallax errors as their use depends on the feel of the operator. Dimensional tolerance as close as 0.0005 mm can be obtained. The end and line standards are initially calibrated at 20 plus and minus half degree temperature. Celsius temperature changes influence the accuracy of the standards. Care should be taken in the manufacturing of end and line standards to ensure that the change of shape with time is minimum or negligible. Table 2.3 gives a complete comparison of line and end standards. Comparison of line and end standards table. Wavelength standards. It is very clear from the methods discussed earlier that comparison and verification of the sizes of the gauges pose considerable difficulty. This difficulty arises because the working standard used as a reference is derived from a physical standard and successive comparisons are required to establish a sizing of a working standard using a process discussed earlier, leading to errors that are unacceptable. By using wavelength of a monochromatic light as a natural and invariable length unit of length, the dependency of working standard on the physical standard can be eliminated. The definition of a standard of length relative to the meter can easily be expressed in terms of wavelength of light. The use of interface phenomena of light waves to provide a working standard may thus be accepted as ultimate for all practical purposes. However, there are some objections to the use of light wavelength standard because of impossibility of producing pure monochromatic light, as wavelength depends upon the amount of isotope impurity in the elements. However, with the rapid advancement in the field of atomic energy, pure isotopes of natural elements have been produced. Cadmium 114, krypton 86, and mercury 198 are possible sources of radiation of wavelength suitable for the natural standard of length. There is no need to preserve the wavelength standards as it is not a physical one. This standard of length is reproducible and the error of reproduction can be of the order of 1 part in 100 million. Finally, in 1960, at the 11th General Conference of Weights and Measures held in Paris, it was recommended and decided that krypton 86 is the most suitable element if used in a hot cathode discharge lamp maintained at the temperature of 86 Kelvin. According to the standards, meter is defined as 1650763.73 into wavelengths of the red-orange radiation of krypton 86 atom in vacuum. This standard can be reproduced with an accuracy of about 1 part in 109 and can be accessible to any laboratory.